So next up we have Klaudia Dussa-Zieger, and I'm very excited to see her, and I believe, as you, very interested in what she has to show us. But maybe a few words about Klaudia. She's team leader responsible for consulting and Imbus. She's interested in test management, continuous improvement of the test process, as well as professional training and further education of testers. And I think that you know that already, but Klaudia is also a president of whole ISTQB. So yes, huge applause to her. That's why I'm so excited, and I'm kind of shaking already. But yeah, Klaudia, the floor is yours. Testing and AI, how do they go together? And you should be good to go.
Thank you very much. Welcome from my side. I'm very thrilled to be here. I hope that not my qualification as an ISTQB president really drives you here, because I think that is almost the smallest part. AI and testing are two passions of mine, and I just want to set the expectations a little right. I am by training, I am a computer scientist, but not a neural network architect. I'm not a data scientist. So what I would like to actually take you with me is on a journey, what I learned since 2018, 2019, because that is the starting point when I actually did look at AI. Back at my company, that was the point when customers came up to us and said, what do you think about this AI solution? So it is more about really what is AI, and this is the agenda. So what is AI? My brain works like that. I need to understand a little bit the history, where is it coming from? So if you are an AI expert already, relax for the first 10 minutes, because it will be a repetition. So we're going to be looking at AI from the beginning, and it will be like a personal review. And then I would like to present to you, do we really need AI in testing, and show you 5 examples that we actually, of projects, 4 or 5 examples that we actually did at Imbus, the company I'm working for. The examples on the slides are actually stuff that is already closed and finished, and I will describe 2 more projects that we're currently working on. So that will be the biggest part. Testing of AI is a tiny little part. It's still necessary, but I was asked to point you towards the EU AI Act, which has some stuff to say about testing, and that actually also talks about qualifications that are necessary, and that actually leads me to the Certified Tester AI testing syllabus, and this is where my ISTQB work comes back, because I was also part of the group that developed that syllabus. And then a small summary. So bear with me, I'll try to be in time. Perhaps it will take a little longer, 5 more minutes or something like that. Okay, testing or AI basics. Now, when I talk to customers, when I talk to new colleagues, some of them, not all of them, but some of them have the impression that AI started with ChatGPT. I'm pretty sure most of you know that that is not the case. AI has been around for way longer, and in my personal time scale, the first block is from the 40s to the 60s, and my starting point is actually the Turing test. You might know Alan Turing, who was also responsible for deciphering the Enigma during the Second World War. He came up with a thought experiment to test whether a machine is intelligent. And he already published that in 1950. So the publication was in 1950, so we're talking 74 years ago. His idea was the Turing test: if you want to figure out if a machine is intelligent, you have a room. You are in the room and you place questions, and you place questions to 2 different rooms, to the right, to the left in this case. In one of the rooms, you have a machine. In the other room, you have a human being, a person. You send out your question, you get back the responses, and if you cannot distinguish whether the response came from a machine or a human being, then he said the machine is intelligent. He did not specify how long, and if you're asked nice questions or malicious questions, so he didn't specify all of that, but if you couldn't distinguish from the feedback what it is, he said it was a smart machine, an intelligent machine. That was the wording, and that is the Turing test. 1956, we have the famous Dartmouth Summer School, where a number of scientists came together from different disciplines, really very interesting, and coined the term artificial intelligence as a research area. Back then, and here you can see the group, I think there were 11 people with very famous names if you're coming from computer science, so Marvin Minsky, Claude Shannon, so a lot of guys that have been doing groundbreaking research. They came together and said, we want to look at artificial intelligence, what is it? And if we go back into that period, 1940s to 1960s, what did they actually look at? And there are from the very beginning two kind of thoughts, schools of thought, let's put it that way. One is to mimic the human brain, which is the subsymbolic AI, and on the other side we have the symbolic AI, where you explicitly model knowledge and then you make deductions, you deduce them. You get new knowledge out of the facts that you have some theorems and you deduce them. And interesting enough, these two schools have been there from the very beginning, and the very first paper where Frank Rosenblatt actually modeled a human neuron was published in 1958, and that is this, you can see it, and that is actually this mathematical function back up there. That was in 58, so also not yet 70 years, but also quite a long time ago. So that started in 58, and this explicit modeling with deduction techniques based on mathematical logic. So if A is true and B is true, then perhaps C is true or not C is true, whatever, depending on how you have your connectors between the terms. So that started very early. And as you might imagine, that with one neuron, the research didn't stop. So from one neuron, they already went to neural networks. So that big buzzword that is in the air right now has been around at least for 60 years. And from the deduction techniques, they also made some progress. They developed some new theorems, some new stuff in there. And the area of AI, and this is something that is, from my point of view, is really important to state. AI is a very, very broad topic. It's not just neural networks and machine learning. You have search techniques up there. And for example, they also came up with programming language dedicated to support them. And the reason why they're up there is because I had to learn Prolog at the university when I was studying. So Lisp and Prolog are languages that kind of model the mathematical deduction. Prolog is Horn logic, Horn clauses, where you can automatically deduce stuff. So that was already back then. We're talking about at least 50, 60 years ago. And I'm not sure, looking at your faces in general, you're younger than I am, but any Lisp or Prolog programmers, did anyone have to do it? No. Wow. Okay. So that was 60s to 80s. And given the fact that AI is the big hype topic right now, it is also interesting to notice that AI was not a success story from the beginning or all along. We have the first AI winter roughly in the time of 1973, 75, up to the 80s, where a report has been issued, have evaluated the current status of the research in the area of AI, and it was said that it's not worth to spend more money there because it wouldn't be really sustainable on an industry level. So governmental funding went down, and that's where the term AI winter was actually coined. Nevertheless, us being curious human beings, research of course went on, and we have the next era, which is then from the 80s to 2000, where the focus was more on knowledge-based systems. So here we have systems where you explicitly model the knowledge, so we're talking about symbolic AI. For example, in the medical domain, systems where you have a number of input parameters. If you have fever, if you're sensitive to touch, if you're feeling nauseous, and so on, then the system would deduce that you have following sickness. So they have been around. There are multiple examples of that. We have the same also if we're looking at games, for example, playing chess, and that will be an example in a second, where you defined or describe the rules how to play chess, and then the system would play with you. So these systems have been brought up and developed, but they also have been hard to maintain. It's a lot of effort to set them up and hard to maintain. And in this era, and of course these knowledge-based systems were coming up, of course the work on the deduction, probabilistic reasoning also went on. And in this era, we have the first, I think the first major awareness in general public. We have Deep Blue, and here, if you know it, perhaps if you're a chess player, Deep Blue is a machine that was developed by IBM. It was a chess computer where, with brute force, with a lot of processing power, it played against the world chess master back then, which was Garry Kasparov, and it won. And that was a major thing. A machine beat a human being. Wow. And that was back in 1997, 1998, depending on to which match you're actually looking at. Back then, it was a rule-based system with enough processing power to actually do the calculations. As I just said, setting them up, maintaining them, having the processing power, go back 30 years, how much processing power did we have back then? The second AI winter came. So the interest went down again, the interest in knowledge-based systems went down again, and now we're slowly approaching what is currently understood by AI if you look into media, and that is actually machine learning. A lot of interest is right now with machine learning, and we can also see that in the gaming part of the application. So here we have a chess computer based on rules where you would deduce the next steps. Here we already have a system that is set up on a neural network. The example you have here is actually AlphaGo, which was published in 2014, and it is a system to play Go, which is a different type of game. You have a larger field, you have more options to actually draw your pieces. You only have two pieces, you only have like black and white stones, but the space of opportunities, the space of next moves is way bigger, so there was no choice. You couldn't come up with a computer or with a program that would actually solve your problem or play Go with rule-based systems, so they went on and actually used a neural network. With AlphaGo in that first version, they were using it based on training data on lots and lots of games that people had played. They trained it, and then later on, AlphaGo 0 and Alpha 0 right now, they expanded that model. Now they used two neural networks that would play against each other, so they just gave them the rules. They didn't give them any training data. They just let them play against each other, and that system learned within days how to play chess and how to play other games. So even if you look just at the chess computer industry, you can see the development from rule-based systems with symbolic AI moving to sub-symbolic AI. And this is where we are right now. If we look into the newspapers, if you look at most of the applications, about 85 to 90%, we're talking about machine learning. Machine learning by itself, you learn from data, which you get in most of the cases. If you look into our media, they're talking about neural networks, so in that combination. So artificial neural networks are part of the game, and definitely the learning algorithms are part of the game. Why is the breakthrough now, or starting 20 years ago? We have had artificial neural networks already 50 years earlier, and I think there are two reasons for that. Number one, processing power is way cheaper. We have a lot more processing power at a lower price right now, so we can do a lot of calculations. Number two, and in my opinion the more significant reason, is actually that we now have electronically available data. If you go back, and for comparison, let's make a time jump by 30 or 40 years. If you go back to 1984, The ARPANET was just on the rise. We didn't have the internet yet. We definitely didn't have any smartphones. We definitely didn't have any social media accounts, nothing. So the availability of electronic data where you could train your neural network on back then was very limited. In comparison to today, just look at the information that you spread electronically within the last day. Participation here at the conference, I was checking in with my airline app. I was already texting in WhatsApp, of course, LinkedIn publications. So the amount of data that we produce every day is amazing. Just try to think if you would like to erase everything, that doesn't work. So, wow, we have a lot of information that we're providing, a lot of data that can be used for training. And this is what is typically understood by AI in the media. And the latest hype now is generative AI with large language models. And of course, ChatGPT has been a game changer then back in November 2022. To get you a little bit to an understanding of the basics, I will spend like 2 slides on neural networks and 3 slides on learning algorithms that you have like a basic understanding, and then we're done with the theory. So what is a neural network? You already saw that little paper that was up there on the timeline. You have a neuron that gets input from other neurons. Each connection has a weight. You sum up the weights and the values, and then you activate it. So you decide what you want to give as an output. In the original publication from Rosenblatt, it was a step function. Now there are different other options that you can use. This is one neuron. If you want to come up with a network, you will typically have an input layer where you enter your problem. Then you have a lot of calculation in between. And then you have an output layer where it tells you, for example, if you input a picture of an orange and an apple, it does the calculation, and then the output tells you it's an orange or it's an apple. All these connections have weights with them, and during our training, during the learning phase, we are adapting these weights. And this is the point where you can, I think, easily see that having massively parallel processing units with graphical processing units or tensor processing units is where it helps us to actually do the calculation. What you see here is a schematic view of a neural network just with input hidden layers and output layers, in this case just 5, and I'm pretty sure it's not really hard to understand that this is just for explanation purposes. Real networks look completely different. Network architectures have been developed and evolved over time. Convolutional neural networks have been up there, and this is actually a YOLO network, which we used in one of our projects, so that's the reason why it's here. You can see the number of layers is way bigger. Here you have one from Google, and just to give you back the connection to ChatGPT, this is a schematic of the transformer architecture that ChatGPT 3.5 is using. For 4 and for 4.0 and for Open.01, nothing is yet published, but for 3.5, they used this new architecture where you have an attention mechanism where you can define the context, and that really did the trick. So the T in GPT stands for transformer technology, or transformer architecture. In that architecture for 3.5, we're talking about 96 layers, and the number of parameters, and this is where it really kind of blows at least my mind, the number of parameters they're trying to optimize during learning is 175 billion. So that is, at least my brain doesn't work like that. That is nothing that I can explain how they actually really do it. It's way too big. And these are the large, if we use that, that's the large language models. The smaller ones, and that is kind of neat, the smaller ones, they're talking about 7 billion or 3 billion, but still billions, so still lots and lots of data. Enough of neural networks. With respect to learning, in principle, there are 3 learning approaches. One is with supervised learning, unsupervised learning, and reinforcement learning, and of course all combinations you can do. For supervised learning, you use training data, and the training data has to be labeled. So if you want to recognize cars, people, pedestrians, bikes in a scene, you will have lots of pictures like that, and you will have these labels so that you can check after a training iteration whether the system really recognized it properly. You can use supervised learning, for example, for this is pictures of brain scans where they try to classify whether you had a tumor or not. So you have these scans and then you can say, yes, it's a tumor or not. You can use it for multiple classification for image and speech recognition. This is where you would typically use supervised data. The second way is unsupervised learning. Here again, you have data, but it's not labeled, so you don't know what it actually is, and the type of problems you're trying to solve here is slightly different. Imagine that you have a set of data points, and forget about the colors right now, just imagine they would all be black, and you try to cluster them. In this example, you would tell them you want to have 3 clusters, and you would give them the center points, and then the algorithm, the neural network, would learn and would optimize the distance of all data points to the centers of the clusters, and then you would get a proposal with a little green cluster up here, a blue one up here, and a red one with the biggest one up here. And this type of learning, where you have not labeled training data, this is used when you're doing classification, when you're doing clustering, when you're doing compression. So if you want to minimize the number of parameters that are needed for a problem, then you could do this compression thing. It's used for coding, for encoding. So that is the second type. And the third type of learning is completely different because you don't have training data at all. For the third type of learning, you need a defined environment, and chess is a nice game because the world of chess consists of a field consisting of 8x8 slots or 8x8 fields. You have a set of different figures that you can move. You have black ones, you have white ones, and the moves they can make are also defined. So the environment is defined, the number of actions they can take is defined, and then you have a reward function that is also clearly defined, that you want to beat your opponent at chess. So this type of learning is different, and you can use it for systems that have these clear scopes. That is typically games, but it's also these vacuum robots, because the room is clearly defined, the limits are there. That thing normally can't fly, so it has to run around two-dimensional on the floor. So this is where you can use it. And web shops also, the recommender systems there are also using that kind of learning function. And of course you can combine them all. Coming back to ChatGPT, they used a multi-stage approach. They started with supervised learning, and then they did reinforcement learning, but with human intervention. So they actually had lots and lots of people looking at the results and judging, evaluating whether it was okay or not, and then they would change some of the weights. Enough with the learning algorithms. If we go a step back and look at AI from a more generic point of view, AI is actually a set of problems that we want to solve, where we are expected to act intelligently. That is like the overall problem range. Then we can, within that big area, we can use machine learning. And machine learning means that you have data, and from this data you want to learn. So the system is supposed to recognize some patterns to make some connections. That is machine learning. Machine learning you can do with a number of techniques, but most of the times right now it is done with neural networks, so based on the networks we have seen so far. And then we can come up with the term of deep learning. This is where you really have networks with lots and lots of layers, and that's what's typically used today. And now if we're doing the next step and going to generative AI, it is kind of sitting orthogonal because again, you can do generative AI, in particular large language models, with machine learning and neural networks, but you can also do it with different techniques. So what is the difference or the new aspect with generative AI? You're not just classifying and saying this is an apple or an orange. You're actually, based on the data that you had and upon which you learned, you're actually generating new context. So you're generating new text. Like ChatGPT, you're generating new videos or images. I'm not sure, I don't know whether you already use DALL-E or whether you already used Sora. So this is what is currently out there, and large language models, neural network for large language models, that is the latest hype. And as I said, you can also use genetic algorithms or hidden Markov models. There's a lot of more techniques. And in general, this is also not something new. We have generative AI systems already back in the last century. We have a system developed by Josef Weizenbaum, which is the ELIZA system, where you could talk to an intelligent machine who was supposed to mimic a psychotherapist. You could ask them, or you could tell them, oh, I'm not feeling well, and then she would respond, well, what is the problem? What is exactly bothering you? And then you can talk to her, and you could carry on a conversation. Not in the sense like you could do with ChatGPT right now. You had to type in commands and you would get it back, and then ELIZA would actually give you feedback. And of course, this is rule-based, and here again you can see the evolution of AI systems. So ELIZA was rule-based with Siri and Alexa, who definitely generate text. We're talking about neural networks, and ChatGPT with transfer learning and with this transformer architecture is the latest step. And ChatGPT, at least in the general public, really opened up their, or blew their brains or opened up their minds to AI, because everybody is talking about ChatGPT, which has been around since November 2022. As we have seen so far, AI has been around for more than 70 years. Why is it that with ChatGPT everybody says, wow, what is it? And I think there are 3 reasons for that. Number 1, it is really easy to access. If you go back to November 2022 or January 2023, whenever you had the first contact, you just needed a browser, nothing more. It left the expert niche, because people have been working in this area for a long time, but it left this expert niche and now was available to everybody. You didn't have to install anything, nothing. So browser-based, number 1. Number 2, it was really cheap. The public version, you didn't have to pay a thing. Yeah, even the professional version, you don't pay a lot, $20-something. So it is relatively cheap to actually use it. And number 3, with the advances in the architectures, with this transformer architecture and with the pre-trained stuff, ChatGPT has been trained, if you believe different sources, at least for 9 months, perhaps even more. The quality of the responses is amazing. And you can ask it everything. It's not just a IT nerd crowd thing. You can ask it to write a poem for the anniversary of your grandmother. You can ask it to plan a city trip to Barcelona. You can ask it how to ski. You can ask it everything. It might not always give you the right answer, but at least you can ask. So I think this is what actually really did change the game. Everybody is now aware of, wow, changing the game. That is okay. No, that's fine. We can. If you're okay, we can keep it like it's like a movie theater. It's kind of. So yeah, this is, I think, what the big game. Well, okay.
You wanted,
perhaps we could. Yeah, like middle thing. Okay. So this is, for me, always important to understand where is it coming from. Yeah, this is perfect, thank you. Where is it coming from and what is it in general? And now we're coming to testing with AI. And we started, as I said, in 2018 to look into it. It was actually triggered by customers. We were at the last Eurostar before Corona, which was 2019 in Prague, and AI was the hot topic already back then. And then we said, okay, we need to look into it and really try it out. So looking at the general testing process, from the planning through the analysis and the design and everything, where can we use AI? And I have to tell you, we can use it all over the place. You could use AI to analyze requirements and try to make them better. You can use AI to specify test cases. You can definitely use it to support you with scripting. I think perhaps a lot of you already have used Copilot or Code Swisher, where you can get a lot of information or code snippets done by AI. You can use it in actually testing self-healing tests, where you can recognize the changes in the GUI, and also analyzing bugs, analyzing large data. This is something that AI can really nicely do. So do we really need it? Do we have to use it? Well, I think given the fact that in our world, let me just click through the animation, in our world the delivery cycle of new software is going down. We're getting new software not 3 times a year, but we're getting new software on a monthly basis, on a weekly basis, on a daily basis, depending on the system you're looking at. If you're looking at e-commerce systems, on a minutely basis. So the delivery speed is getting smaller and smaller. So we're getting more and more systems that we need to check. The connectivity is going up. Go back 40 years. Your refrigerator didn't have a piece of software. Right now, if you take the latest model, they want to connect to the supermarket and order food that is missing in your refrigerator. So the connectivity is going up. The number of systems you have to look at is going up. It doesn't only have to be, if we look at the end device, it's not only the laptop, it also has to work on the tablet, it also has to work on the mobile, so you have to have responsive design. And the requirements with respect to performance, everything has to be fast. If you look at your smartphone, you want the answers, the results right now. Everything should be secure in the ideal world. And digital accessibility, now with the new legislation coming up, is also a topic. So the forces that are getting towards us, what we have to do is going up and up, so the number of tasks is growing, and I think we can use every help that we can get. For me, AI is a supporting tool. It is like test automation frameworks helping me to get stuff done faster or easier. I'm not personally, I'm not threatened by AI that my job will be lost, because we will be around and we will need to check what they're doing, and we will have to set it up, and we will need to think about ways to use it in a proper way. Our jobs are safe. They will change, but we will still be needed for sure. And I think we could really, really use it. Let me give you some examples. Number one, this is some work that we actually did with one of our colleagues who did his bachelor thesis on it. That was work done back in 2020. And he was looking at similarities of requirements. We have several customers that have large development units, different groups working in different locations, and occasionally they come up with the same requirements. So we thought back then it would be nice to see if we have duplicates, if we have requirements that are very similar. And he looked into it and looked at the different ways how you could do it. This is a very simple one where you can just see from the wording that they're very close. So talking about a template from an existing element in a tree, and talking about a template in a tree view, that is language-wise very close. Then another thing that he looked at is the context window. Depending where the word you're looking at is located in a sentence and in the larger context makes a big difference, because the interpretation is then different. And for me, the most exciting is actually the so-called word movers distance. And what you do there is that you actually take sentences like President Obama the president greets the press in Chicago, and Obama speaks to the media in Illinois. What you do there is you get rid of all the fill words, the articles and stuff like there, so you're left with 2 sentences consisting of 4 words. President greets press Chicago, and Obama speaks media in Illinois. Then you train the network. You build up a multidimensional space. You convert actually the words into a numerical representation, and then you get distances between the words, and then you get a similarity index that speaks and greets are pretty close, and Obama and president, that was like a couple of years ago, not right now, is very close. And if you look at all these words, it will give you a similarity index, a shortest distance between these words, and you can have a look at it. Again, this is not deciding by itself whether it is similar, but it's giving you a hint. So it is supporting you, it is an aid for you. And that worked really well. That was number one. Number two is in test specifications. This is work that has been done with large language models back then with ChatGPT 3, 5, and 4, and also with back then with BART, work done last summer, where a customer said he wants to get test specifications for a system. He doesn't have the requirements yet, and his employer says he can't put real requirements into ChatGPT because who knows who's reading the requirements. So a security issue. They were not allowed to actually use ChatGPT or BART with the real requirements, even that they didn't have it. So what did we propose? What did we do? We actually said, well, if you can't use the requirements because there's some company IPR in there, what about, and I'm sorry, I missed that part. We're talking about a medical device company. What about if we use a user manual, how to use your medical device? That information, the user manual, is out in the internet. If you have the proper keywords, you can find it. So what we did is we actually fed in the user manual and asked it to derive test cases, and they were very amazed how well it worked. Now on the slides, I'm very sorry I was not allowed to use their stuff. They were a little strict on that, so I thought I'll use a coffee machine. Testers are very well, and developers also are very familiar with coffee machines. So this is actually the part of the user manual of a Jura machine. I didn't even check if you have one out there. But a coffee machine, and you can see there is quite a lot of technical information already in there. And then we started with a very simple prompt and asked the system to derive test cases. And you can see we already get the test case name, we get already a reasonable number of steps, and we'd get expected results. And that was a first try prompt where you would just ask it to develop test cases. If you do it in a smarter way, if you improve your prompt, for example, giving it a context, saying that you are a software developer or a tester in that environment, that you are an expert in the medical or in the coffee making domain, and you want these informations filled in, or you want to have the test steps in a tabular format, it will do that. And this is what we did. So if you refine the prompt, you will get test case IDs. Again, that's what we had before. You will get preconditions. You will get the test steps with test data and the expected result per step. You even get priority proposals or categories. It's a positive test, it's a negative test, and stuff like that. So that worked really well. Did they use it? No, they did not, because they were still not allowed to use ChatGPT. But now, starting this year, they have a local copy, so it's a big company, they paid enough, they have a local copy of ChatGPT, and now they're using it. An example of a project we're running right now is a customer, again, who has high security issues with these kind of solutions. So what they did there is come up with a private cloud. We're working with AWS, and we're having a meta language model in there. Actually, we're using Llama 3.1, and that customer said he's not interested in using ChatGPT because it's a general purpose thing. He just wants to have it for the creation of test cases. So it's really a dedicated system, and we have been training that, and it's now in the pilot phase with the testers to support them. What is the motivation for him to ask for a dedicated specific system in a private cloud? Again, it's a different customer, but still medical device. They're working on the next generations of their devices, and they know from historical data that test specification takes them 5 days. Being in a regulated environment, they need to review it, so all these effort taken into account, it takes them 5 days. And he said, if we can just reduce that time by 20%, if the local AI specification component saves them 20% of the time, and they are expecting 4,000 to 5,000 test cases, that means they would save 4,000 to 5,000 days, which is several man-years. So for that reason, management was more than happy to spend the money. So no issue with money and funding. It was just an issue with actually getting it done. And by the end of the year, we should get the results of the pilot phase, and I hope I can do a presentation next year how it actually really went. Oh, and that is the summary. So that is a real-world example that we're working on right now. Number 3 is actually using image recognition for test automation to have more robust tests. When would you need that? Well, if you don't have another way to really grab that information, if you don't have a proper ID or an XPath, then it could be necessary that you actually go through images. What you want to achieve is that you have, if you have a login form like that, and due to whatever reason you have something like that, that your script still can work like that, that the AI recognizes that these are the same fields. And this was a little ambitious because we tried to do it by ourselves. I wouldn't do it again. Next time we're going to use a proper tool. But back then we used the YOLO 3 network. We had actually a water metering system, so a system that counts your water flow, which had about twice that size, with a little digital display, half that size, so not very big. We didn't have an API, and we thought, we're going to try a neural network. What we did is we needed training data, so we took a camera, made 5,000 pictures, so we took 5,000 pictures, and the idea was to actually be able to recognize whether the display is working properly, whether the water is flowing in the proper direction, and stuff like that. We trained the network and we gave it to the team, and the team said, it's not working. So it had a hit ratio 48, 52, sometimes it was working, sometimes it wasn't working. And then we tried to analyze what the problem was. Why is it not working? We thought we did everything according to the book. And the problem was actually the data. We took 5,000 pictures and we thought it was enough, but no, it was not. What happened was actually that when you take a picture with a digital camera, it puts a timestamp in there. And our system had learned to distinguish timestamps. Out of the 5,000 pictures we took, only 200 had changes up here, but every picture had a change down here because you do it by the second. So we definitely had learned a lot because the input data, and if you perhaps have been to the presentation on data bias in the previous time slot in the next room, data is an essential part when working with a neural network. You train on the data, and if the data is bad, the result is bad. As easy as that. The neural network will only feed you back or mirror you back what you put in. And if that is bad, if that has a bias, you will see it. It doesn't help. So no, it did not work, and next time we are not going to do it by ourselves, we're going to use a tool. But we learned a lot, And that is the last example, which we already closed. This is work that has been done 2 years ago. In defect classification, we had a customer that has been developing software for a long, long time, more than 15 years. And not, perhaps that also happens to you, not with every release they did really close all the bugs. So they had a database, a defect base that was growing, and at that point of time they had more than 103,000 bugs in there that were not closed. Happens. And the question was, what can we do with that? And they came up with a solution to actually classify the bugs. So what we were using orthogonal defect classification. That is a technique or proposal coming from IBM. It's already quite old, where you can classify defects. And we looked at the impact classification, and we gave it several key terms, so the system went through all the bugs, and at least we could cluster it, whether it is a performance issue, whether it's an installability issue, whether it's a functionality issue or reliability. So we could cluster it, and then we also did some more training and labeling to see whether it was a severe issue or not. And then, like the similarity index with the requirements, we had like the top 10% high severity for different types of quality characteristics, and then we looked at that. So it was, again, an aid to help you with your work, because nobody wants to go through 103,000 bugs that have been closed, that have been in there for 10, 15, 18 years. At this point of time, just be aware, not everything that the AI gives you back is correct, yeah? Automation bias, just make sure that you check at least every now and then whether the result or the answer it's giving you is really the right one. Oh, and one last comment, something that we're working on right now is support in digital accessibility, support when writing the report. If you have the list of defects that you find in digital accessibility, you're forced to give an improvement suggestion, and this is what we're actually currently working on to present that text, that it is generated by a large language model. Will these little helpers, these little gimmicks be around? Yes, I think so. This is a website that checks or that lists the number of AI-based applications that is around. The website is called There's an AI for That. I don't know if you already had a look at it or not. It kind of tracks the number of applications over the years, and this is statistics that you can get. So there were 3 in 2015, and additional 7 in 16, and additional 31 in 17. And you can see that in 2022, the number already popped up, and this is the number for 2023. And this is the reason why I say it's not going to go away. I'm not saying that all of them will stay around, and I'm not saying that all of them are related to testing, for sure not. But the interest, the easy availability, the availability of open source large language models that you can just play around and try it out is there, and it will not go away. We will have it for sure. And that is my sharing of project experiences, and I hope that we will have some more next year. Now, testing of AI systems. AI systems have been around for a long time and in a lot of different domains. If you're having a modern car with assisted driving, your car is already recognizing the environment around. It's able to recognize the lane. It's able to read street signs. That's all image recognition. That is, if you want to call it, that's AI. We have it in recommender systems. We have it in the medical domain for a long, long time. Tumor cell recognition, clustering, that has been around for a long time. So testing has to be done. If you want to look at different, let me just click through again. If you want to look at different approaches to test these systems, you will find different ones. This is a presentation out of a paper, which is quite nice. And you can see that traditional testing, like integration testing and system testing, is there. But then in general, 2 new test levels are added. And one is testing of the input, and I think that is desperately, desperately needed, so that you really test the quality of the input data, and then you also need to test the quality of the model itself. Is it doing a proper prediction? Does it have the accuracy that you want to have it to? And these are techniques that can be used. Some you might already know, like equivalence class partitioning or boundary value analysis, and some are actually really new, like metamorphic testing or mutation. Well, mutation testing is not really new, but other types of testing. This is a kind of short paper. If you are interested, there is from my point of view, a very nice standard on testing of AI system, which comes out of the 29119 series. And of course, being the president of ISTQB, I'm going to show you briefly. This is the 29119 part. The major component, the major chapters. After an introduction, it talks mainly about the testing of machine learning systems, and then it has different black box and white box techniques, and a little bit about test environments. And here they are. But being the ISTQB president, I would like to point you towards the AI testing syllabus. And that is work that has also been done before ChatGPT. That is a syllabus that was already published in 2021, which has come from 3 different sources and which is actually currently updated. And if you look at that one, you have a large part with an introduction, and then you start looking into testing. Here we have the test levels, and here we have the different techniques. And this is the test levels. Again, this is pretty much, I guess, what you know: component testing, component integration testing, system testing, and acceptance testing. But these 2, The input data testing, where you really focus on the quality of the data, and the model testing, where you look if the ML model really does what it is supposed to do. That is what we need to look at. Now, why is it, and here are the techniques. Here are the techniques. Why is it important? And this is actually the bridge to the EU AI Act. The EU has published as the first standard in the world to regulate AI. That has been discussed for quite some time, and finally in July, in the middle of July, it was published in the official journals, which means that the EU AI Act is in force starting on the 1st of August. And what they do there is that they do a risk analysis of the different components, of the different AI systems. I mean, risk analysis, risk-based testing, I think is pretty well known to all of you. And in that risk assessment, the EU defined some systems that are not acceptable. So the social scoring, as you can see in China, is not allowed in the EU. But we have the major piece, the heart of the EU AI Act is actually the requirements around high-risk AI systems. And these are systems that reflect to security, that also reflect to systems that are considered critical system from other standards. So cars are in there, airplanes are in there, transportation systems are in there. These are high-risk areas, and these need to fulfill certain requirements. You need to show compliance. Then we have moderate risks, where we just need to show transparency, and then minimal risk. But for these high-risk systems, what do we need to show? And this is where my heart as a tester opens. It needs to be tested. You need to show that it performs for the intended purpose, and you need to show compliance with the EU AI Act. And it has to happen under real-world conditions, not only in a laboratory, not only in an AI sandbox. So this will come. Given the fact that the EU AI Act came into force 1st of August 2024, you have now 2, and depending on the exact area, in some 3 years to actually do it. So we will have to do it. If you are developing an AI component or using an AI component in your larger system, you need to do this risk assessment and really have a look and make sure that you tested it properly. And besides the fact that you need to test the system properly, you also need to make sure, and this is article number 4, you need to make sure that the people that are working on it are educated. And I'm not saying, don't get me wrong, I'm not saying that the certified tester AI testing is going to solve the world. There are plenty of AI training material out there, but it is one piece that goes into that direction, and you need to show that you trained your people, that you educated your people. So, summing it up, I think personally, animations, that we will have a set of small little AI supporting tools. At least that is what we see in our projects right now, dedicated small applications that will be in use in order to help us increase our efficiency. But you will have to be in there as a human quality gate with your human normal brain and see whether the system is telling you or giving you some sensible information or just talking complete bullshit. So it will be there. And AI is not going to go away. So look at it and think about using it to support you, like an additional colleague, like an additional person supporting you. And keep in mind that there is more than just large language models. So that is from the perspective of testing with AI. Now, testing of AI, the number of systems that will have AI is increasing, and we will need to test it. So we need to work on our skills. I think personally, working in IT, testing also, but working in IT, looking at how the technology was when I started and how it is right now, it's a lifelong learning anyway, but we also need to spend time and look at AI. So my advice would be work on your skills, check the syllabus, but also look at different parts. I would be more than happy, but they need to be tested, and we need to make sure that we are skilled to do it. And I'm very sorry that I'm running over time, but that was the last slide. Despite that lunch is smelling and calling. Questions?
Any questions?
Yes.
Two questions, Klaudia. First, you mention about it, but you don't give us a you mention about it, but you don't give the solution. Many companies does not want to promote the way how to prepare test cases and so on. If you learn your artificial intelligence tool, you need data. How many time? Well, this example with many photos. How long? How many time you need to teach the automata? And the second question, I asked too. According to last things I found in some American paper, I don't remember the name, this AI computers are very hardly electricity consuming. You know the question.
Yes,
so
I know the question.
So you know the question. I don't need to finish.
So let me start with the second question. Training such a system, if you look at ChatGPT, it takes a lot of energy. It takes a lot of time, a lot of energy. Green IT, sustainability, sustainable goals is a big topic. The system, for example, the system we have been using for that one customer, which is a private cloud in AWS, it's a very small system. So I don't think that we're using that many resources. I admit we haven't measured it yet, but in our company we have some very green people, and they say, why do you use AI? Just use your brain. Yeah? Yes. So I think there will be more focus on that topic. That will come for sure. Now, with respect to the resources that you actually really need to train, what we did for that company is that we used a pre-trained model. We used the Llama 3.1, so it's already pre-trained, and we didn't train it any further, so we didn't use fine-tuning. We used actually the retrieval augmented generation approach, where you give it additional information. So we gave it some architectural specifications, some design specifications, and also some user manuals. And from the requirement, when you have this information, you put it in a vector database, you put it in nice little chunks, and then you combine this information, and then they come up with the test cases. So setting up that system, actually training it, getting it to do that chunking properly took us about 2.5, 3 months. It wasn't really that huge, and it was not unfortunate. It wasn't really that expensive, because the hardware was less than 8,000 euro. So we had 2 GPU cards, which were a little better, or top of the list, but not really that so we're not talking about hundreds of euros. We're talking about less than 5-digit number. And then 3 months time, And actually 3 months time with 2 guys who were just coming from the university, very keen in machine learning and wanting to set it up. The experts from the company, from the medical device company, they were just kind of using it, but they didn't have the expertise to participate in the development, because they could just provide the documents, and that was it. So it is a knowledge thing. That's my perspective. A lot of companies want to use it, but they have to learn the technology, and right now, I don't know who's fresh from the university, and let me rephrase my statement. When I was studying in the last millennium, we had an AI chair that was doing symbolic AI, who was teaching Prolog and Lisp, and it was closed in 2000. So 2000, no more AI at the university in Erlangen. If you look at the university right now, we have like 13, 14 chairs on machine learning, in the medical domain, in this domain, in that domain. And if you get people from there, they already know the algorithms, they already know the architectures, they have a completely different approach to the entire thing. There's no barrier. So they're up to it and they want to explore it and they're very happy. So the two young guys are quite happy doing the project. So 2.5 to 3 months. And as I said, the prototype is now being developed. Now we have the issues of getting a security issue again, of getting people to be able to reach that model in the AWS cloud because they have some security problems there. So we need to talk with the IT of the customer. And then the prototype phase is till the end of the year. So by next year, I can tell you more if it works or not.
Thank you very much for detailed answer. And we have one more question from the audience.
Actually, just fulfilled all the answers for my question. But in addition to the first question, did you try to estimate the cost at the beginning of the project?
Yes.
When we were using this big LLM?
Yes, we did. Because we had an upper budget, so we had to look what the hardware would cost like. So we said we had a limit for the hardware, and we had a number of hours that we could spend. Yeah, so we did.
Thank you very much.
Yeah, we did.
Okay, great. So thank you, Klaudia. Huge applause to Klaudia once again.